Hi, my dear students. Myself Prasanna Kumar, Assistant Professor, Department of Electronics, Sri Ramakrishna College of Arts and Science, would like to handle a session on EHT, sound section, AM limiter, and FM detector. These topics are related to audio video communication subject. In this slide, we are going to discuss about what is EHT in TV. EHD is nothing but a extra high voltage transformer. The main purpose of this extra high voltage transformer is used to take the electron beam towards the target of your screen. Though this high voltage is generated with the help of this transformer, and it is mainly used in the CRT monitor of your TV. CRT is nothing but a cathode ray tube. So why we are using the EHT in TV receiver? A circuit which is mainly used for supplying the final anode voltage to the CRT from an horizontal output. This horizontal output is obtained from a horizontal deflection amplifier. This horizontal deflection amplifier receives the input from the horizontal oscillator. The horizontal oscillator receives the input from the high pass filter circuit. The input to the high pass filter circuit is a synchronizing pulse. The synchronizing pulse consists of horizontal pulse, equalizing pulse, and vertical synchronizing pulse that is given as an input to the high pass filter. The high pass filter will process the horizontal synchronizing pulse. The horizontal synchronizing pulse is nothing but a spikes pulse which is obtained as an output of high pass filter circuit. That output is fed as an input to the horizontal oscillator. The horizontal oscillator works at a frequency of 15,625 Hz, which will convert the spikes pulse into a sawtooth wave. That sawtooth wave frequency ranges is around 15,625 Hz. That is given as an input to the horizontal deflection amplifier. This horizontal deflection amplifier will process the signal and it will be given as an input to the circuit. This prevent the ringing duration during the scanning time, and also it will helps to improve the regulation of the output voltage. In this slide, a circuit arrangement was shown to explain the operation of EHT. The input to the horizontal deflection amplifier is a sweep generated signal that is obtained from the output of horizontal oscillator. The frequency range of this sweep generator is 15,625 Hz. That sweep generator is applied as an input to the horizontal deflection amplifier. This horizontal deflection amplifier will amplify the incoming sweep signal and it will transfer the output to the next stage. The next stage of a circuit is made up of a flyback converter transformer. The flyback converter transformer has two windings. The primary winding is connected to the boost B plus supply, which is a low voltage, which is mainly used for finding and filtering of the supply voltage. The other end of this flyback converter is winded with the heavy voltage winding, that is number of turns at the secondary is more than that of the number of turns at the primary. So according to this, the voltage will be produced more at the secondary winding. That produced output voltage will be fed as an input to the high voltage rectifier. The rectifier receives the high voltage signal which are generated at the end of flyback converter. It will process and it will rectify the signal applied at the input, and it will transfer the output to the next stage. The next stage is nothing but a cathode tube of the CRT monitor. The CRT monitor cathode will receive a high voltage signal. That high voltage signal is ranges from 15 kilowatt to 18 kilovolt. In this slide, I have given a explanation for the circuit diagram which is shown in the previous slide. EHT is an extra high transition which is generated by the help of a transformer to produce a high voltage. This is to produce the high voltage at the output of your transformer circuit. The input to the horizontal deflection amplifier will be a synchronizing pulse which is obtained at the output of horizontal oscillator. The synchronizing pulse is nothing but a sweep generated signal. The frequency of the sweep generated signal will be around 15,625 Hz. The horizontal deflection amplifier will amplify and deflect the applied input signal, and it will process the output to the high winding of the transformer to produce the high voltage. The other end of the transformer is applied to a low voltage, and it is referred as a booster B plus, which is used for finding and filtering the supply voltage. The transformer used in the circuit is a flyback transformer. The EHT coil, EHT is nothing but a extra high transition coil which is connected to the secondary of the FBT that has very number of turnses, that is very high turnses which are winded at the secondary to produce a high voltage at its output. The voltage obtained at the output of this EHT is nothing but a 15 kilovolt to 18 kilovolt, which is processed toward the CRT anode. This generated signal will be applied to the anode of the CRT to move the electron beam towards the target of the screen. In this slide, we are going to discuss about the next topic. The next topic is nothing but a sound section. The sound section is mainly used in television receiver for processing the sounds with respect to the loudspeaker. First of all, in this block diagram, the radio frequency signal which is received by the antenna consists of very high frequency and ultra high frequency. That is given as an input to the tuner circuit. The tuner circuit will receive the input signal, and it will generate a intermediate frequency signal at its output. The intermediate frequency signal is applied as an input to the picture IF amplifier. The picture IF amplifier will receive the signal, and it will amplify it, and it will process the output to the next stage. In the next stage, we have a video detector. The video detector will detect the IF amplified signal, and it will separate the audio signal and video signal in this video detector. The video signal separated from the circuit is given to the next stage. The next stage is called as a video amplifier. So until this video amplifier stage, we have an automatic gain controller which is used to control the gain of your voltage generated at the circuit. The output of the video amplifier is post processed again with an video output amplifier, and the output of the circuit is given to the picture tube of your TV. The output from the video detector is an intermediate carrier signal which consists of some amount of video signal and also an audio signal which is applied as an input to the sound takeoff circuit. This sound takeoff circuit will receive the input, and it will eliminate the unwanted video signal, and it will process the audio signal to the next stage. The next stage in this block diagram is nothing but a sound intermediate frequency amplifier block. This block will receive the sound IF signal and it will amplify it and it will feed the output to the next stage. The next stage is nothing but a sound detector. The input to the sound detector is a frequency modulated sound signal that is demodulated in this sound detector. The demodulated output consists of a original sound information which is fed as an input to the audio frequency and power amplifier circuit. Here the amplification take place and the original sound information is increased in its strength and it will process the output to the loudspeaker. The loudspeaker will reproduce the original sound signal at its output. In this next slide, we are going to see what are the stages that are available in your sound section and what is the technique used in this sound section of your TV receiver. In the sound section of the TV receiver, mainly depends upon the technique called frequency demodulation technique. This sound section consists of the following stages. The first one is sound takeoff circuit. The second one is sound intermediate frequency amplifier circuit. The third one is an FM detector circuit. Fourth one is an audio frequency power amplifier circuit. And the fifth one is a loudspeaker circuit. In this slide, I have explained the two blocks that are used in the sound section. The first block is nothing but a sound takeoff circuit. The intermediate carrier sound signal and the video signal which is detected from the video detector is applied as an input to the sound takeoff circuit. The circuit which will take off the intermediate carrier sound signal from the input and it will feed the output to the next stage. This is the purpose of sound takeoff circuit in this sound signal. The next block of this sound section is nothing but a sound IF amplifier. The sound IF amplifier will receive the intercarrier sound signal from the signal takeoff circuit and it will amplify the intermediate sound signal. The strength of the intermediate sound signal is increased in this block. The amplified IF signal is then fed as an input to the sound detector, which is the next block in this sound section circuit. In this slide, I have given an explanation for the sound detector circuit and audio frequency power amplifier circuit of the sound section. First, we will discuss about the sound detector circuit. The input to the sound detector circuit is a modulated intermediate sound signal which is applied as an input to the sound detector. This sound detector will demodulate the intermediate frequency signal and it will extract the original sound information and it will process the output to the next stage. The next stage in this circuit is nothing but a audio frequency and power amplifier circuit. This audio frequency power amplifier circuit will receive the sound signal which has a lower strength and it will process the signal, it will amplify the signal and it will increase its strength and it will produce the output to the next stage. The next stage in the circuit will be a loudspeaker circuit. The main purpose of loudspeaker is to reproduce the sound signal at its output. This is the process of loudspeaker. Next, the intermediate frequency of the video signal at the TV receiver has a frequency range of around 40 MHz. From the video detector, a intermediate frequency of sound signal with a frequency of around 5 MHz is extracted and it is applied as an input to the sound takeoff circuit, which will have some amount of video intermediate frequency also. The sound takeoff circuit will process the signal and it will transfer the information to the other stages to produce the sound signal at the output of your loudspeaker. This is how the sound sections are generated at the television receiver. In this slide, we are going to discuss about a new topic called AM limiter. Here, I have given the definition and the explanation for the definition of the amplitude limiter circuit. The purpose of amplitude limiter is used to limit the amplitude variations that are received from the FM modulated wave. That is the definition of this amplitude limiter. In the explanation, first of all, we are going to see about the FM signal which has a carrier frequency. Those carrier frequency will be a varying one because according to the time constant of the signal, the wave will be a continuous wave. So the carrier will be a varying one. If so, if there is any variation in the amplitude of the received wave, then it is said to be a noise or interferences. Those noise and interferences has to be eliminated from the communication channel to produce a proper sound signal at the output. For this purpose, we are in need of a circuit. That circuit is nothing but an amplitude limiter circuit, which will limit the unwanted variations in the amplitude of your sound signal to produce the proper sound signal at the output of your circuit. Here I have given you a circuit diagram for the AM limiter circuit. In the circuit diagram, the input applied to the circuit will be a FM modulated wave. The FM modulated wave is applied to the primary of the transformer circuit. The primary of the transformer circuit will process the signal by using a magnetic flux and it will transfer it to the secondary of the circuit. The secondary is connected to the base of the FET circuit. This will process the signal and it will produce an output at the primary of the second transformer. At the secondary, you will receive an amplitude limited frequency modulated wave at the output. Here the explanation is given. By examining the DC condition, we will get a supply voltage which has dropped through the resistor RD, which is shown at the output of the secondary circuit. Also, we will have a leakage at the gate of your FET by supplying the parallel combinations of biasing between the resistor RG and capacitor CG. Finally, the FET will show a neutralized output at the capacitor Cn to produce a high frequency operation at the AM limiter circuit. Here I have shown you a waveform of AM limiter circuit. The input will have a different amplitude variations at the output. After the limiter circuit, the output what obtained at the end of the limiter circuit is shown at the top of the waveform. When the input signal is applied to the circuit, it will raise the current flow and it is given to the resistor RG and CG biasing circuit and it will produce a negative voltage which will make develop across the capacitor. It is seen that the bias of the FET is increased in proportion to the size of the input voltage. The bias of FET will be increased according to the size of the input voltage. If the input voltage is low, the biasing to the FET will also be low. If the biasing is more, the size of the input will also be more. As a result, a gain of the amplifier is lowered. Once the gain of the amplifier is lowered, the output tends to remain in a constant position. So this is how we are going to limit the amplitude of the varying signal in this AM limiter circuit. In this slide, we are going to discuss about FM detector circuit. The FM detector is a circuit which is mainly used to convert the frequency changes from a carrier signal to its output voltage. This is also called as a frequency demodulator or discriminator circuit. There are different types of circuits which are used as a FM detector. That is what shown in this slide. The first circuit is nothing but a quadrature based FM detector circuit. The second circuit is PLL based FM detector. PLL is nothing but a phase locked loop. The third circuit is Foster Seeley discriminator circuit. The fourth FM detector circuit is a ratio detector. The fifth circuit will be a slope detector circuit. All these has its own circuit arrangement to demodulate the FM signals from its intermediate carrier signal. As I said before, we have five different kinds of FM detector circuit for detecting or modulating the frequency signals applied at the input of your FM circuit. Here, the most commonly used FM detector circuit is nothing but a Foster's Seeley discriminator circuit. The detector consists of a special center tap transformer feeding two diodes in a full wave DC rectifier circuit. This Foster-Seeley circuit is arranged in such a manner it is like a center tap transformer is splitted into a two circuit by using a diode to produce a full wave DC rectifier output. When the input transformer is tuned to a signal frequency, the output of the discriminator will become zero. Once the output of the discriminator becomes zero, there will not be any process at the output. When there is no deviation of the carrier, both halves of the center tapped transformer will become balanced. Once it is balanced, the FM signal swings in a frequency above and below that makes the carrier signals too varied. Then the balance between the two halves of the center tapped secondary is destroyed and there is an output voltage proportional to the frequency deviation of your circuit. In this slide, a circuit arrangement is shown for the Foster-Seeley discriminator circuit and the explanation for the same is shown at the left hand side of this circuit. First of all, the frequency modulated input is applied to the primary of the transformer. The secondary of the transformer is splitted into two and one end of the transformer secondary of the transformer is connected to diode D1 and another end of the secondary of the transformer is connected to diode D2 and it is separated by a center tap point and it is connected to the RF choke. The output of the diode D1 and D2 is connected to a capacitor C3 and C4. The output of the capacitor C3 and C4 is connected to a resistor load R1 and R2. The output of resistor load will produce an audio output. The explanation is shown at the left side of the circuit. The Foster-Seeley provide a high output and has a low distortion. The circuit resembles like a full wave bridge rectifier circuit. If the input equals the carrier frequency, the applied input equal to the carrier frequency, the two half of the tuned transformer circuit produce the same rectified output at the diode D1 and at the diode T2. So when the same rectified output is produced at the diode D1 and D2, the output of the circuit will be a 0. As the frequency of the input signal changes, if the input applied FM signal changes its the frequency, there will be a different signals that are generated at the output of diode D1 and D2. So the balance will be take place between the two half of the transformer secondary. This will result in producing a voltage proportional to the frequency deviation of the applied input carrier signal. This is how the FM signals are detected and it is demodulated and it produced the output of the FM detector circuit, which is nothing but a audio signal. Here we are going to discuss about the another FM detector circuit, which is nothing but a ratio detector. This ratio detector is a variant of Foresti-Seeley discriminator. The circuit arrangement of the ratio detector has a slight change when comparing to the Forster-Seeley detector circuit. There you have two windings at the transformer. Here you have a three windings at the transformer. There are three windings that are shown in the diagram, and the output of the capacitors are fed to the third winding to produce an output at the end of the capacitor C7. This circuit arrangement is also considered like a full wave bridge rectifier circuit. The ratio detector will produce the output between the sum of the diode voltage and according to the center tap of your transformer. The output across the diode is connected to a large value of a capacitor, which is mainly used to eliminate the noise which are occurring at the circuit. The ratio detector has an advantage over the Foresti-Seeley discriminator, that is nothing but the response of the AM signal will be eliminated. Thus, potentially saves a 50% of the output of the discriminator for the same input applied at the input terminal as an FM signal. The ratio detector has wide bandwidth but more distortion than the Forster-Seeley discriminator. So we are going for Forster-Seeley discriminator detector circuit instead of this ratio detector circuit. This is how the detection take place in the FM demodulation circuit. Thank you for watching my presentation. I hope so you have understood all the topics which we have discussed in this presentation. Thank you.